Okay. Now it should be recording.
You want to rewind just briefly to the first slide or something?
Yeah, I'll just. Yeah, I was saying that the Hive CI relies on mainly three services: Jenkins, Artifactory, and Rsync service, and everything is hosted on a Google Cloud cluster. And we started discussing about Jenkins and the main login page, that is this one. And in order to, we started discussing about the access and permissions. So we're saying that anonymous access is disabled for security reasons. And the authorization is based on a GitHub authorization plugin, Jenkins plugin. And the privilege, the exact permissions are configured by a matrix-based, but by the matrix just below. And we can see that authenticated users have permissions to check the job status and probably download some test artifacts, etc., etc., etc. And Apache, the people who participate in the Apache group, Cloudera, or Hortonworks group have some extra permissions. So normally, like for instance, for restarting a build via the Jenkins, normal just authenticated users cannot do so. So they can only do it by raising a pull request, pushing a commit on the pull request, closing and reopening, and stuff like that. While normally Apache committers, people in Cloudera or Hortonworks should be able to also restart the build by clicking the necessary button in Jenkins. The main thing to keep in mind is that is there a question on the chat? Okay, just in case, feel free to interrupt and open your mic, because it's difficult to switch between the screens and check the questions in the chat. So whenever you want to ask something, open the mic and do it, okay? So yeah, I was saying that if people need extra privileges to do some testing, to build some new jobs or whatever, they can send an email to the dev list and ask for extra permissions. So usually, if they are if there are Hive committers of PMC members, any kind of such request will be granted, and I can we have already some Jenkins administrators who can add you and give you extra things if it's necessary to do so. So the main jobs that we have so far in Jenkins are the following. So we have a CHK job that is runs every few hours and basically does some very primitive tests to see that it can contact the underlying cluster. Then we have the Hive flaky check, which is a job that you can configure in order to confirm or reproduce a flakiness issue. So you can pass some configuration arguments, and the job will run the same test like 100 times. So if it fails, it means that it's flaky. So you can get the URL and paste it to a pull request to confirm or that the flakiness is fixed or that the flakiness exists. Then, apart from this flaky check job, we have two nightly jobs. Hive Nightly is runs once per day on Apache Master, and basically creates some snapshot artifacts and pushes them on the repository, the Apache repository, for internal consumption. So this used to work, but as I mentioned yesterday, it is broken for a month or so. So currently we don't have snapshot builds for master. And the nightly branch, the nightly job for branch 3 will soon be removed. So apart from that, the main job is the Hive pre-commit one. But yeah, I will talk about it just after that. So I will just finish up this slide with the space check job. So the space check, what it does, it runs on demand and also on a daily basis, I guess. And it prints the disk usage for each the disk usage that each PR consumes. So basically, in the past, we had some issues where the disk space was of the Jenkins was exhausted, and Jenkins was basically failing. So this, by checking this job, you can spot such problems. So if a PR occupies like many gigabytes of space, you will see it there. So if there are no questions here, I can continue with the main job, with the Hive pre-commit job. Okay. So the Hive pre-commit job is the core job that controls everything, all the pre-commit tests that are running. And as you can see, if you check the job in Jenkins, you will see that it's divided into two parts. One is that it runs on branches, and the other that it runs on pull requests. So basically, this job will run on everything that has a Jenkins file. An important thing to remember here is that if we have many branches, like branch 4, branch 3.1, and we push commits there, it will trigger runs. And in general, yeah, since we don't have separate resources for each branch, everything uses the same underlying cluster. So that's why I was saying in some recent emails that if we want to maintain multiple branches, we may not have the resources to do so. And also another thing to keep in mind is if you create your own branch under the official Apache repository, just for an example, I will let me talk about. You see, there is a branch which is called dependent bot, or you see some other branches which is called Hive aggregate reduce function rule. So every commit that you push there triggers a run. So if you are building a feature, keep in mind that this consumes CI resources. So this, yeah. So if you don't, if it is just work in progress and you don't want the CI to run, don't create branches here. Let's say don't create. Just have your personal clone under your user space in GitHub and push the branches there. Is everything clear here?
Yeah.
Okay. Cool. So as I was saying, everything here, everything that it runs on this Hive pre-commit job is controlled by the Jenkins file. And the Jenkins file can be found in the Apache repo. So so far, the job is split into like, okay, let me use the Blue Ocean UI that is more intuitive. So we have like four serial parts and some parallel ones. So obviously the serial part is like you need to check out the code, you need to run some basic pre-checks that do not take more than a few minutes. And then it's the basic compilation phase. And then we have something that is called upload. I'll detail a bit more of that later on. And then we have a series of parallel steps that are used to perform, like, say, some metastore initialization checks. Currently, we are doing it only for Derby and Postgres. In the past, we had some other databases as well, but for flakiness reasons, I think these are disabled. We have a step that builds a Java doc, so to ensure that everything works fine and we don't have issues that we find out late in the release cycle. We have a check that to ensure that the nightly build succeeds. And this is interesting because I think that the nightly build, for instance, here just checks that the build passes, but does not actually push anything to the Maven repository that can be consumed by end users. So that's why we have a nightly job that's currently broken, while in fact the build on every PR passes. And then we have a step that is doing the Sonar integration. So this has some static code analysis, and we may have code coverage in the future. We don't have right now, but we may incorporate it here in the future. And then those that also take the most of the time is running the tests. So this incorporates unit tests and Q tests, which Q test is more like end-to-end test. And here we have like 22. Now we have 22 splits that are running more or less in parallel. And this takes roughly 1 hour and a half. So this is
on the step number 3. Like, why does it take 40 minutes for that stage?
For the compilation?
Yeah. What kind of? I mean, what does it mean, that compile step? What does it actually mean there?
So the compilation stage is like a compilation. So it's MVN clean install with some other arguments, but it's mostly that part, I think.
So it's 10 minutes on my machine.
Yeah. So why this takes 40 minutes? Because we are downloading. Basically, we are running in isolated environments. So we are running in Kubernetes pods that we are going to see afterwards. So we have nothing. We don't have a Maven local repository there. So we start from scratch and we download every single jar that we need. So I think this is the part that takes most of the time. So that's why it takes 40 minutes. I think that's the reason, but yeah, worth confirming. And this is also, yeah, go ahead.
Sorry, do you have some like internal artifact repository? So like kind of cache, so you don't. Okay.
Exactly, yeah. That's the second service that we are going to see, which is the Artifactory service, which is exactly that one. So we are not actually fetching artifacts from the Maven Central, but we are fetching them from an internal Artifactory. So an internal repository manager that is much faster. So every request goes there.
Hey,
okay.
One more note, if you can hear me.
Yeah, we can hear you.
Yeah, I'm assuming that in compile time, in the pre-commit we enable the dist profile maybe. Is there a chance? I think you can remember that when you remove this cyclone or something from the non-dist build, because this adds huge overhead to the build. So if we build it with dist, it becomes much longer than the usual build time on our laptops, where we obviously don't build with the dist profile, I guess.
So basically, almost all profiles are enabled. So yeah, that's also a big consumption, but I think the biggest one is sending requests to the repository manager, to Artifactory, and getting the artifacts. But also, of course, like building with this also takes like maybe 1/3 of the time or 1/4 of the time.
Yeah, exactly.
Yeah, sorry, also one remark. regarding the Java doc, I think we are building Java docs for all the models, including the I test with all submodels as well. And
it's very likely.
Yeah, probably we don't need it, right? So why do we need Java docs for the test models?
Well, yeah, we could drop it, but from the other end, we are also releasing stuff from iTest. So,
and
from the
do
moment
we
that
need documentation for that part?
we probably nobody cares, so we could drop it. But in the same spirit, we could also stop releasing those things. But that's a bigger discussion.
Okay.
Anyways, I mean, there are lots of improvements, and one reason that I wanted to do this presentation is like because we all see these kind of things, and from the moment that we see, somebody else might take an initiative and fix something. So everybody, all these kind of comments are very, very useful, and somebody here may have some cycles to fix things here and there. Okay, yeah, just a quick comment here because it was brought up in the discussion. So I was saying that we are pulling many jars from the Maven repository, from the Artifactory repository. And this is actually where the upload part is necessary. Because as I was saying, like all the things that are running in parallel, it's separate step there that you can see from the split 0, 1 to 22 and the nightly build and the Java code and everything is running on a isolated pod, which is different from the node that we compiled the project. So basically, we are going to take all the compiled artifacts, all the Maven repository that we built locally, and we are going to propagate it to its separate pod. So we are going to propagate it to the 22 pods that are you can see there. So we will see this in a bit more detail afterwards, but I just wanted to mention it here because we mentioned the big compilation time and the artifact download. So is it okay that we move on? Okay. So in terms of debugging, we have a few places that we can check when something goes wrong. So one place that we can check for errors, exceptions, and other stuff is the full Jenkins log, which can be found under each job ID. So you can see here that for the master run on the 2618, the console text has all the information that was generated during the Jenkins build. So this is obviously a nice place to check for problems, especially when it is infrastructure related or Kubernetes related. When it comes to test failures or problems hangs in tests or flakiness or other kind of these issues, we can download the test results archive from the link that you can see here. And then basically there we have all reports from Surefire. We have some Hive logs that we retain for failures and other useful information. So lots of stuff can be found there. And then another kind of place where we can find useful information is the flow graph table. And this may become handy when we want to associate tests that were running in a specific Kubernetes pod. So if we want to make the association, usually we need to look there. And another useful thing for debugging purposes is the inclusions txt file. So basically, as we have seen previously, the tests are split, the unit tests and the Q tests are split in 22 parts. And there is a Jenkins plugin that does this. And basically what it does generate 22 inclusion txt files that are passed to the Maven Surefire plugin. So each split uses this file to control which test to run. And in the Kubernetes infrastructure, this test, the whole split takes about 1 hour and a half. Usually when we run this locally, it should be under an hour. So if you have some failure in a specific split, and you see it like failing twice in a row, it is very likely that it can be easily reproduced locally, if you use the same sequence of tests. And you can run the same sequence of tests by using this inclusion txt file. So basically, you can see all the tests that were run. And then it becomes easy to isolate the problem. Like you run it once, you see that it fails, and then you can quickly remove parts of the test that were not relevant, and you can basically come down to the barely minimum. So I'm mentioning this because many times we say it's flaky, let's disable it, and it is fine to do that. It's a good thing to do. But even better is reproduce a failure and fix it. Usually it's not that difficult. So if it fails twice in a row in your PR, consider also checking if you can repro locally and disable it. This is usually easy.
And where can I find those files?
So if you check, so I think that this file may be also part of the test results archive, but if it is not, if you check the PR step, the prepare step of the prepare step that is running on Blue Ocean, it has a cat command that prints this file. So basically, you can find it there.
Okay.
So if you click, do you see my cursor or not? The mouse.
Yes.
Okay. So if you click the prepare step here, normally down in the logs, you will see the inclusion file.
Got it, thanks.
Anything else?
Is there any way to rerun the pipeline from a specific failed stage? Like only if it's flaky or any particular split is failing in rerun as well. Is there any way?
No, unfortunately, it's not possible to rerun from a specific stage. And it's basically impossible in parallel pipelines. So Jenkins simply does not have the feature to restart a step. You can restart it if everything is sequential, but not for parallel. So in our case, it's useless, basically.
Okay. And any way to set the priority for a specific build, like if we want to, if we are rerunning and it's the priority is urgent for the PR, is there any way to prioritize the build?
Basically, no. I mean, there is a way to override the queuing mechanism. So normally, for instance, each PR has a limit, so you cannot run a single PR cannot be run more than 4 or 5 times per day.
Mm-hmm.
So if you reach this limit, there are some hooks. So users with permissions can manually restart the job from Jenkins. But if you keep pushing commits to the PR or if you try to close or reopen, it will not work. So basically, yeah, that's the only way to overcome.
Okay. Thank you.
You're welcome. So now a few stuff about, so when we want to change stuff about the tasks and the checks that are running in the pre-commit jobs, everything can be done with a Jenkins file. So normally we don't need to touch anything more than that. If we happen to want to install things, new Jenkins plugins, or do some changes in the Jenkins itself, then we have to touch the image. So for instance, recently, or not so recently, but we had some Jenkins plugins had some security vulnerabilities. So to solve that, we had to upgrade the Jenkins instance and also upgrade some plugins. So this needs actually changes to the Docker image. And currently, the latest one can be found in the pull request that I have in the link here. It was never merged, so that's a bit unfortunate, but if somebody wants to check the latest image that was used, it is there. And it is, the actual image is pushed to this registry. So in Docker Hub, there we have a Apache Hive CI Jenkins space. So the image is pushed there. And the actual deployment can be found by running this Kubernetes command. So, and one sample or like one deployment that was active at some point in time, probably it's obsolete by now, can be found in Zoltan's repo. So if you want to get really the latest and the one that is actually used, probably you have to manually get it from the Kubernetes cluster. So all these things around Kubernetes will become more clear once we touch this part. So if you have questions, we'll see more things later on. Are there questions so far? Because I think we are going to switch to Artifactory now. Okay. So as I think Dennis correctly mentioned before, like if we're fetching every artifact from Maven Central in the pre-commit jobs, things would be extremely slow. And actually, we would probably get banned, not from Maven Central, but from other repositories. So what is actually happening is we have an Artifactory service that we are going to see just after. And basically, in order to tell the pre-commit job to only fetch artifacts from there, we have a settings XML file that is can be found in Jenkins in the following URL that I have put there. And basically it says that no matter which repository is defined in the project, we are always gonna fetch artifacts from this special kind of repository, which is Artifactory Wonder. So this is a global mirror, and we are fetching artifacts only from there. And this is a step why we want to have an Artifactory service. So the Artifactory service can be found in the following URL. I put it here just for reference purposes in case people want to find it afterwards. In terms of access and permissions, things are pretty limited. So probably everyone can see the general page, this page. But there is no LDAP in place, there is no single sign-on, and there is no authorization plugins. So basically, if somebody needs access to it, probably it has to ask in the dev list or in some person that is an administrator to give him access. So basically, if you want to do changes, nobody can do apart myself and a few other people. But yeah, anybody can get access to it. It's not difficult to do so. Currently, the Artifactory is configured with 7 remote repositories. So you can see the list here. I will not go into each detail into each one of them. But what I wanted to mention is that basically, if for whatever reason we add some custom repository in the Hive build, probably the pre-commits will fail. Because if the remote is not defined here, the artifacts cannot be obtained. Just an example that is relevant. So for instance, let's say that we want to test the test, a test release candidate, which is deployed in the special repo. And so from the repository apache.org, or the same stuff if we want to test a release candidate from CalSite. Basically, even if you put the repository, the Maven repository, directly in the POM file of Hive, it will not work. It will fail to fetch the artifacts, and you will get errors. And this is because this Artifactory does not have this remote. So if you want to add more stuff or remove stuff, this is a place to do. And the whole, the way that this whole thing works is because we have this kind of special virtual repository that is called Wonder. And this Wonder is actually, let's say, a proxy of the 7 remotes that we have seen before. So I will just go back briefly to see why we have Wonder here. So the Wonder that we put in the Jenkins configuration is exactly that, is to this virtual repository that exists in JFrog. Is everything about how the Artifactory comes in place, is everything clear here?
I have a question about like the consistency of this repository. So is it, so let's say there is some new artifacts published. How soon does it make it into this one?
I think it will do it immediately. Like it works also like a cache. So if it has the artifact already, it will not send even a request to Central, for instance. If the artifact is not found, it will try to fetch it from Central or from all remotes that are configured there. And it will basically, success or failure, it will be cast, and based on the configurations, it will retry at some interval.
I see. Okay.
Does the answer your question?
Yeah.
Okay.
Thank you.
And okay, yeah, just a quick thing, since we are here, is that at some point in Cloudera, because we are also using Artifactory, but it's on a different URL, we had some problems because we were running out of disk space. And this is easier to happen internally because we have many different builds and we generate many more artifacts that are stored. So yeah, just to give you a bit of perspective why we had this issue downstream and we never had it upstream. So in terms of the Artifactories, again, it's a service that relies on a Docker image. And basically we are using default, we don't have any kind of built-in Docker files. So we are taking exactly the 6.18.1 version that can be found in the bin tray. And the actual deployment can be found again by probing the Kubernetes cluster. And one such deployment can be seen also in Zoltan's repo. So if at some point you want to upgrade to a more recent Artifactory, probably you have to change the Docker image in the Kubernetes deployment. Okay, and now we are going to see the last service. This is going to be quick. So the Rsync service. This is also controlled through the Jenkins file. So if you check the Jenkins file, you'll see some save workspace, WS, or load WS commands. And these are actually taking place, as I said before, in the upload phase and in the prepare phase. So the Rsync is a utility that uses its own protocol. And it's basically a way to efficiently transfer files. In this case, we want to transfer, as I said, like all the jar files that are in the Maven local repository that will build during the compilation phase, and also all the kind of jars that were built, the Hive jars. So everything will be put inside into this kind of archive.tar file, and we'll use the Rsync utility to transfer them back and forth from one Kubernetes, from one Google Cloud node to another, so from one pod to another. And the reason why we are using Rsync is because it can see if the file is already present and if it is identical, so that it avoids the copy if it is not necessary. So again, this will become a bit more clear afterwards. But since let's say each parallel step runs in a different pod, but it may happen that the same pod runs in the same underlying node. In that case, for instance, we will not spend time transferring the archive because we can get it. It's already there, basically. So in terms of, I guess it will be rather unlikely to make changes to the Docker file for Rsync. But again, the Docker file can be found. I think the latest one is on Zoltan's repo. I don't think we ever touched it. Maybe I'm wrong, but the file is there. We are using the Docker registry, and this is a bit tricky because here we are using at the moment the Zoltan's Docker Hub account, which means that if we ever need to push things there, we have to contact Zoltan, or alternative, we have basically to change the deployment and push it somewhere else, which is okay because we already done it in the past. So I think we are done with the,
So are we running some pod to do the Rsync like copy jar activity? Is it some init container or?
Yeah, so we are going to see all these things right after. So if I don't answer the question here in a few slides, feel free to ask again. Okay. Okay, so we have seen like the three main services, and now we're going to see actually where all these are running. So the cluster, the Kubernetes, and all this kind of stuff. So as I said, everything runs, at least for Hive CI upstream, everything runs on Google Cloud. And the project is this one that is mentioned here. So it is gcp-hive-upstream. So if you click this link, you will be able to get to this page, assuming that you have permissions to do so. Obviously, yeah, somebody pays for this project, for these services, for these cloud VMs, and that's Cloudera. And this is why actually in terms of access and permissions, things are a bit more restricted. So here, the access is restricted only to Cloudera employees. I don't think if this can change, I doubt, but I think that given that we have so many people contributing to Hive from Cloudera, and given that we don't need to touch this part very often, maybe things are fine as it is. Anyways, for Cloudera employees, I think that many people are already administrators or have accesses to this cluster. If you need access and you don't have, you can contact, you can send a message to the, probably, yeah, anywhere, either the dev list upstream, either the internal Slack channel that we have for Hive infra, and you will somebody will add you. For reporting problem and suggestions, yeah, the dev list and the Jira ticket upstream is a good way to do so. So if something does not run as expected, feel free to raise an issue there. So yeah, so we have a Google Cloud cluster set up already, and we also have so everything runs in Kubernetes cluster. The name of the Kubernetes cluster is Hive Test Kube. So here is, for instance, the command. So yeah, Google Cloud offers a command line utility that is called gcloud. It's easy to install. There are instructions already in the project that you can follow to install it on your machine. So I did this rather recently, and everything worked fine. But if something needs additional clarification, again, feel free to send a message to the Slack channel, and we can clarify and solve any kind of difficulty. So this command that I copy pasted here is basically to see the available node pools. So basically, we want to see the machines that are available in this for this Kubernetes cluster. So we have two node pools, so two kind of machines, the slave pool 9 and the core pool 2. I didn't pick the names, so we can see also some very brief information like the disk size that is used, that is in size of gigabytes, and the machine type. The machine type is actually about how many CPUs, how much memory, etc., etc. If we want to get more information about each node pool, we can send this describe command. So you can do container node pools describe and put the core pool that we want to see the configuration. So currently, this does not have auto-scaling. The core pool does not have auto-scaling, and it uses an SSD of 100 gigabytes. For the slave pool, auto-scaling is enabled, and we can have up to 8 nodes here. And here the disk size is 160 gigabytes. So summing up, like for the core pool, we have 2 nodes that are running, always on. There is no auto-scaling, so these are always running. And the slave pool has 0 to 8 nodes. So if nothing is running, if we don't have pre-commit jobs, this is basically 0. So we cannot see anything here. While these kind of nodes are always on. as we said, like the core pool uses this kind of machine type. And if we want to get more information about the machine for this node pool, we can see that it has 2 CPUs. This kind of information about maximum percentage disks is not that relevant. But what is useful is the maximum memory. So it has like approximately 13 gigabytes. And we can do the same for the slave pool that is used for the pre-commit jobs. And here we have 12 CPUs available on each node and roughly 65 gigabytes. So I summarized all these things here, but I also put the commands in case these things change, if you're going to get to see how many CPUs and how much memory each node has. And the reason that I'm getting into this kind of, for some low-level details, is because this is relevant to understand how things are scheduled afterwards. So if at some point I want to see how many nodes are running, and actually by nodes I mean actually machines, not pods. So I run this command and I can see everything that is actually running in the cluster. So when I run the command, I can see I saw the 2 nodes that were available for the core pool. And at the moment that this was run, it was 3, 6. There were also 7 nodes running for the slave pool. And we can also see how long these were running. Are there questions so far before I go a bit more into what is running in each thing? Okay. So we have the core pool, which has 2 nodes, and each node has 2 CPUs again and again. All this information are already there. So there we are running the Jenkins service, the JFrog Artifactory, and the Rsync, because these are always on. And basically, that's why whenever we click, let's say, to the CI Jenkins link, we're going to find the information. The slave pool just runs when a pre-commit jobs is running. So basically, when the pre-commit jobs are not running, this pool is 0. So nothing is nothing is visible there. So if we want to run all these things that we've seen in the Hive pre-commit job, every kind of step, every kind of task, we need to have available nodes here in the slave pool. And yeah, if we check the pods, let's say all the pods that were running in the Kubernetes cluster at some point in time, we can see like the Artifactory, pod that is always running. So here we can see that it was running for 30 days. We can see the Jenkins pod that's also running for 30 days, the Rsync pod. And we can see also when I ran the command, there were also there were 3 pods running. 1 pod for a master, for a pre-commit job on the master branch, 1 pre-commit job on this PR, and 1 on this PR. I will explain more in detail soon. So yeah, as I said, these were run on the main services are run in the core pool and are always available, and everything related to pre-commits are run in the slave pool. As I said, like this is sponsored by Cloudera, and all this is of course is costing like thousands of dollars per month. I'm not sure if I can share the exact amounts because this might be a big private information, let's say. So I skip that part. But it's in the order of, yeah, let's say under 5,000, but significant per month. And also, as you can see from the chart, it is proportional to the number of the CI runs. So if we can see here, like let's say for March, the cost was significantly more because I guess that there were many more peer pull requests that were run. And why this is also relevant is like for things that when we had, now that we have the release candidate for the 4.1 release, we have more pull requests and more commits and more runs because we are creating a pull request on master. We are cherry picking the commit and creating a pull request for the branch 4.1. So basically all this kind of effort is duplicated. And if we had yet another maintenance branch, the cost would go more and more. And because of course, all these things are limited, things will not scale infinitely. So we should keep this in mind when and if we plan to discuss about future maintenance releases. So let's see about a few more about the naming of the pre-commit pods. Though this is, I think the naming is also controlled by the Jenkins file. So every pod has the PR ID, the branch basically that it's run. If it is run on master, you can see master here. This corresponds to the actual run. So if, for instance, we have this PR was run 6 times. So for each time, you will see a different identifier here. And then you have a generated identifier because for each pre-commit job, you're basically going to have more or less 27 pods. And we are going to see this afterwards. So for each kind of pre-commit pod, so for each, let's say this, for example, let's take this, for example. If we check what containers are running, it will output 3 kinds of containers inside. The Docker in Docker, the HTTP container, and the JNLP. So the HTTP container, actually both HTTP and Docker in Docker are controlled by the Jenkins file. So again, most of the things are controlled in the Jenkins files and more things can be added by changing that thing. And you can see like exactly which CMAT is used and all kind of configurations that we have here. So I don't know if I will mention it afterwards, but what is worth mentioning is that the HTTP container is basically where the compilation is running or where the tests are running. So all the MVN test, MVN clean, MVN stuff commands can be found in this container. So if you ever want to go and check what is happening in the container, you have to go there. You have to check the HTTP container. The Docker in Docker container is actually where the Docker containers that are used by the tests are run. So if you remember, we have some, let's say, Metastore, for instance, tests that are running, that are spanning some Postgres containers, some Oracle containers. So all these are running here. So the request is done, the Docker run command, let's say, is done here, but the container is actually running here. This is just to say, to have an idea of if things start breaking, where I need to look, especially if it has to do with Dockerized tests. And now we are going to talk a bit about scheduling, because this is also important to understand how we want to use the pre-commit jobs and how to use them efficiently. So if you see here, for instance, for the HTTP container, we are requesting basically, let's say, 2 CPUs. We are requesting around 6 gigabytes of memory, and we want to have at least 15 gigabytes of storage space. And if we go back to the machines that we have available, if you recall from before, each node has 12 CPUs, 65 gigabytes of memory, and 106 bytes of disk space. So if we do a bit of calculations, we can see that each HTTP container, so each pod more or less, needs each node can run at most six pods at the same time, at the same point in time. So each pod will consume like 1/6 of the node capacity. So if we put all the nodes that we have in the slave pool, so we have 8 nodes, we have like the capacity to run 48 concurrent pods. And like if we want to run to see, like we have this node, I just picked a random node from the Kubernetes cluster, and I want to see everything that is running there. So here I can see that, for instance, this node has already like 1, 2, 3, 4, 5 pods that are running some split or some step from this PR 5989, and it is the first run. So that is to say that in order to run the full pre-commit for a single PR, for this PR, for 5989, we cannot fit everything in one node. So we will have this separated into multiple nodes. And if we get this again, this familiar image from before, we have like all these kind of things. We have 27 parallel tasks. And each thing here needs a pod. So if we put the capacity that we have, 48 divided by 27, that is the number of pods that are required for each PR, we cannot run more than 2 PRs at each point in time. And if we put all this together, this is not much. Like, I mean, imagine that we are talking about runs, not branches. So something that a CI run on master is competing with a PR run. So now I will do a short pause because I said a lot of things about scheduling, and I didn't leave time for questions. So are there questions here?
Yeah, so do the other things get queued up, or what happens to things that are waiting? Like, and is there like a first come, first serve type of queue or anything like that?
Yeah. There are queues in place, and there are some resources that are locked. So that these are at the Jenkins level. So yeah, things are queued at some point and wait, basically. And at some point, we have also in place some timeouts. So if something gets scheduled and does not complete in time, it will time out in 12 hours. So this is also worth keeping in mind. Like, for instance, you have a PR, that is somebody does something is broken, let's say, and it runs forever. So this will keep eating resources. So everything else will wait for that one to finish. And if something goes very bad, which is like, okay, this is not very likely, but if, let's say, all the splits get hung and wait, nothing will get scheduled for 12 hours. So that is to say that if you see something suspicious, yeah, take a look there. And another thing, yeah, I'm at the end of the presentation, but another thing that we always have to be mindful of how we use the CI is because I noticed, like, for instance, people that are uploading stuff, creating pull requests, and basically either they do not compile, either they are broken because, I mean, you make a test, but you didn't confirm that it is passing locally, and you raise this, you raise a pull request to save time, but doing so will probably waste resources because the full run will fail, and while it runs, it blocks some other PRs from running. So yeah, I mean, always be mindful. In some cases, it's good to get quick feedback, but maybe do it when the cluster is not so busy, or at least do some basic tests before raising a PR so that it's not completely waste of resources.
Stamatis question.
Yeah.
Would it be possible to improve in future these parallel tasks? Can support retry? For example, this metastore task was sometimes failing with this Docker images for initiating schema or whatever, I don't recall. So that it can be restarted instead of running the whole pipeline, just the one.
So from the Jenkins level, it is not possible. It's only possible if you have if you configure it in Surefire level. But again, this is a bit risky to do. I mean, if it is not on demand, if you have always retry enabled, if things get bad, you may have a pull request that blocks everything else. So yeah, it needs a bit of.
In Blue Origin, there is a deck, right, for all these tasks.
Yeah.
Isn't it possible to add some, I don't know, like restart from the last failed or whatever?
Unfortunately, it's not possible to restart parallel tasks. So maybe if we restructure the parallel task differently,
okay,
we could be able to restart some stuff. But yeah, Jenkins does not support restarting from parallel tasks. One parallel task, let's say.
Okay.
Yes, Matters one more thing. Say, can we remove this from the Jenkins pipeline, this metastore DB thing and the Java dog building thing? Remove it from there and put it into GitHub Actions. So it will save resources for us, and there we can restart it, and this will not cause test failures or something like that.
Yeah, I mean, anything is possible. So if you see something that could be done to save some resources, we could put it there. Only downside. I mean, if I recall well, this kind of metastore init steps rely on some stuff that are in the HTTP container. So these are not Dockerized tests that we run regularly, let's say. So yeah, probably it's feasible, but it may be a bit more work, let's say.
Yeah, thanks.
One comment about this, the autoscaler part that you mentioned. So autoscaler is enabled for the slave pool, but it sounds like the autoscaler will only scale up to 8.
Exactly, yeah.
But what is, so my comment is just, let's say, we increase the max number to 16 or something like that, right? The dollar amount that we are paying to Google Cloud will still remain the same because we will be able to complete more things in a shorter period of time.
That's fair. That's correct, actually. The only downside is that if we put it to 16 and suddenly we have people using more, creating more, like if the volume of pull requests increases, the cost will increase because we have a bigger capacity, so we can run more things in parallel. And yeah, I mean, basically, we could double the auto scaling, but if we use it for whatever reason, if we use it at full capacity, the cost may be doubled. So it's easy to do.
Assuming that the PR workload is constant, whether it gets done sequentially or in parallel, the amount will be the same, the dollar amount.
Exactly. Yeah. So we can do that if we get if we are confident that things will be okay like that, and
Yeah.
because otherwise I don't think we can easily put a limit.
We can monitor it, say, for 1 month and see what is the cost coming to, and then maybe we can change it also or downscale it if needed.
Yeah, for sure. So yeah, other kind of questions, comments, because I think I covered everything that I had in mind. So I think that I covered where the CI services are running. They are running in Google Cloud, in the always on dedicated core pool with 2 nodes. For some things, we have access to the CI infrastructure. And people who cannot have access can ask to get permission to do so. We are all in the order of a few thousands per month. So I don't know exactly how it goes for a single, I don't know how much a single CI run costs, but for all CI runs, it is around 5K per month, let's say. So at the moment, it's Cloudera who is sponsoring the infrastructure. All the splits that are in the Blue Ocean interface are basically checks that are controlled by Jenkins files that exist in the Hive Apache repo, and they can and they run in separate pods in Google Cloud. We can run at most 2 PRs in parallel due to the underlying resource limitations. We can see some PRs that are running longer or for longer periods of time, because actually we can run 2 PRs in parallel, but it doesn't mean that things will get scheduled exactly like that. Let's say some PR started, it reserved some resources, and some things took longer to finish. Let's say some tests took 5 hours. So we have like, let's say 3 nodes that are still occupied. So a new PR comes and we'll get, some splits will start, but the other will wait for the resource to become available. So the overall, the total duration may vary for each PR. In terms of tests, if everything goes well, like the test run for 1.5 hours and the whole PR should run in like 2 hours, but it depends on scheduling. So when I should submit a PR, well, I would say that submit a PR when there is at least it passes compilation, and at least some tests were done to verify that things are not completely broken, to avoid stealing resources from another PR that is in a better shape. There is also the possibility to cancel PRs. So if you realize that the run that you forgot something and the run is going to fail or it's not worth finishing, yeah, it's worth canceling the run to save PRs and allow some other runs to advance. When it comes to flaky tests, as I said, in like 80% of the time, it is easy to reproduce the flakiness if you know about the inclusions file, if you know about the splits, and if you know about a bit about the infrastructure. So, like if you see like in 2 consecutive runs the same test failing, I would say like, yeah, don't retry again. Like it will probably fail again. Try to reproduce the failure and solve it, or disable the test, or do some action. Like I've seen people retrying the same test like 5-6 times, and the test fails for 6 times. Like it is flakiness maybe, but it is reproducible. So stop trying, resolve it, and then try again. This I covered like just now. The CI logs and stuff and the artifacts can all be found in the Jenkins runs. They are retained, I think, for PR till it is closed, till the PR is closed. And for master, they are retained for a year, something like that. So all this can be found also in the Jenkins file. There is no way to test just a subset of tests in an easy way, in the sense of retrying something from Blue Ocean, from Jenkins, but you can use the inclusion txt file or the qsplits profile to rerun things locally. So this is possible. So I think that I covered everything that existed here and the things that I wanted to cover. So from my perspective, we can call it a day, unless someone has something else to ask.
Yeah, one more question. What happens on the last step of the build, this collection test results? So usually I saw in a log something like waiting for some agent to spin up, and it was like stuck for several hours, and after that build was completed with timeout. But all the phases were green, but build was reported as failed.
I mean, the last part is usually collecting the results from Surefire. So these kind of test reports that are relevant for creating the test report in Jenkins. And this usually is done on the last step of its split, let's say. And this usually does not necessarily does not require scheduling, because it's already scheduled when in the prepare phase. So it's not scheduled apart. So yeah, we might have to check into the specific failure to answer a bit more into detail about this.
And what's the like normal timeline for this, for collecting results? So it's connecting to all the executor pods and downloading the results of the tests to the main server, to the Jenkins server?
It's basically in the last step, it is uploading the stuff to the Jenkins server.
But why it's taking so much time? Like there are plenty of builds that are like waiting for some, I don't know, agents to be active to do this download, and some like very frequently it fails with timeout.
Yeah, I haven't noticed that. So like, I cannot answer because
Okay.
I will say whatever. I have to
Okay.
check the favor. I haven't noticed that part. But
Okay,
it shouldn't take that long, and I don't think that it's the biggest part. I mean, usually the test run is the longest part. Like we have the prepare phase that takes like a few minutes, depending if we have the artifacts in the node, in the pod, because it's also kind of like some gigabytes to upload the art, to prepare, to download the artifacts using Rsync. So this might take a few minutes, 5 to 10 minutes. Then we have the tests that are running, and this depends. It could be like an hour or something. And then we just create some other kind of jar and we upload it. But this is usually not that big and shouldn't take that much time. So it should be 5 minutes or so. Rough guess.
Thank you for the
Tamas,
presentation.
sorry, just one question. Do we have an umbrella in, for the ideas for the near future or something to make people aware that this is something that we can improve on all the time?
We don't have an umbrella. That's a good point. I don't think we have an umbrella about improvements upstream. So maybe we should. Maybe we should create one. And actually, what I was planning to do, probably after the presentation, I will try to maybe put this into the Hive website so that we have some entry points about all this kind of information that were said here. And we can put there some link to Jira to use a label or to have an umbrella ticket for future improvements. That will be useful.
Okay, sounds good.
So yeah, I guess that's all with the questions. So many thanks to everybody who joined. Like I'm happy that we were like 10 to 12 people. If the 12 people start actively contributing, things will become much better in CI. And also, yeah, this will also facilitate contributions and troubleshooting in general. So many thanks for attending. Many thanks for the feedback, and yeah, looking forward for more ideas on how to improve our CI. See
Great.
you all.
Thanks,
Thanks,
Tamas.
Tamatis.
Thank
For this.
you.
Thanks.
Thanks a lot, Tamatis, for organizing this stuff. Thanks.
Yeah.
Bye-bye.
Bye.